it's really important to get everything you need together in one place. I'm using the mirror to check the sources. Obviously you want to use tongs, forceps, they're called different things. You need some of these filter papers and some lint-free cotton buds, lint-free cleaning swabs I think they call them. Bit of ethanol, don't need a lot of it. A tube, you could use a penny for this, but I found a tube with a 20mm hole on the end is perfect for this. You're going to want some gloves as well, and use a tray, put everything in a tray. Stopwatch, Geiger counter, you know, all the usual stuff. Step 1, the Geiger counter has to be suitable, so you need to check it's calibrated correctly. That means taking this little blue plastic spider thing off the front and putting a potassium test source on the top. You can make those easily. The instructions are linked in L93, the document from CLIAPS. The test has to be done over 1,000 seconds, 16 minutes and 40 seconds. So it does take a while, and all you're doing is counting the activity. A little bit later on, after 16 minutes and 40 seconds, we'll remove the test source, put it away. We'll do it again to measure background, and for whatever reason we have to measure background after we've used the test source. The test source should be placed directly on the top, sat on the top of the Geiger-Müller tube. This is the document you fill in, I've just printed off, and you record some information at the top about the GM tube that you're using, the lead, and you just fill in the information you've got. So I filled in all these details that I can with the unique serial identifier of this particular tube, and anything I don't know, we just sort of left it blank. We're coming up to 1,000 seconds now, 16 minutes and 40 seconds, so let's hit the stop switch. Perfect. And our count's 728, so that gets filled in here. T728. Now what we have to do is remove the potassium test source, place it in the safe, and repeat the whole process again. So the potassium test source has now been removed. I've moved nothing else, well, apart from the tray because I just knocked it. And then what I'm going to do is hit reset on the stopwatch, and we'll start on the stopwatch and reset on the counter at the same time. There we go. And we're going to measure background radiation for, again, 1,000 seconds, 16 minutes and 40 seconds. It's always useful to have one of these on hand as well, permanent marker, so you can label anything that needs to be labelled. Like if we have two tubes, we've got two Geiger-Müller tubes, we can actually label one tube 1 and tube 2 so they can be easily identified. So we are coming up to 16 minutes and 40 seconds. Let's switch the switch. 234 just got in there. 234. So that gets written in here. 234. And then we do this pretty straightforward calculation. Okay, we've got 91.5%, which is higher than 70%, lower than 130%, so that's absolutely fine. Should be quite close to 100%, because that means that we're detecting what we should detect for the potassium. So that is a pass for the beta efficiency test. The alpha efficiency test is very, very straightforward. Just plop an alpha source near the Geiger-Müller tube window, quite close to it. Make sure you've got lots of counts, put a piece of paper in between, and make sure the count's full. It's going to be difficult for me to record that one-handed, but let's just show you this. Hands in the way. Alpha source nearby, lots and lots of counts. And let me put it down and put paper in between. Usually you just slip a piece of paper, but I'm using my left hand to hold the phone. So I'm not going to be able to do that. Right, so there's a piece of paper now there. You'd slip the piece of paper in between, and lo and behold, no matter how close the source is, we're not getting any appreciable, well, not a huge increase. Let me knock the paper out of the way. And then, boom, loads. So that passed the alpha test. And if it passed overall, great, we can use that detector to do our leak tests and contamination checks, that sort of thing. Now, before we can do any sort of contamination checks or leak checks or anything like that, what we need to do is to measure background radiation for where the Geiger-Müller tube will be. So you're going to have a piece of filter paper. These are the filter papers that are recommended. #1 Wattman ones. You have a piece of filter paper underneath the Geiger Müller tube, and it should be just a few millimeters away. Not sure whether you'll be able to see that. It's not quite touching. Just a few millimeters away from the end of the Geiger Müller tube. See, that's not touching there. And then what you'll do is the usual method, so reset and start the stopwatch at the same time. And after 1,000 seconds, that's 16 minutes and 40 seconds, you'll stop this and you'll know what background is. No problem. What you'll do is you'll divide that number by 10, so you know the number of counts in 100 seconds for background, because all of your leak checks, all of your contamination checks, that will all be done over 100 seconds. And you'll be comparing the number of counts in 100 seconds to the background radiation in 100 seconds. The instructions say to use a penny to draw around. I'm going to use this copper pipe. You need to draw a circle that's got a diameter of about 2 centimeters. Well, this is 22 millimeter pipe, so that's close enough. And you pop it onto here. The reason why you're drawing a circle is so you know what part of the paper you are testing. So this is the filter paper. I've drawn the circle. Fine. Then what I'm going to do is I'm going to take the radioactive source. I'm going to test this one. I don't need the cotton buds, they can go out of the way. Right, I'm going to test this source. I'm going to open it up. And let's just test, I don't know, alpha source or something. I've already done all these before. Alpha source, there it is. And what you want to do is, taking hold of the alpha source like this, first thing you want to do is a visual inspection. So that means using the mirror, looking at it and seeing whether there's any evidence of discoloration, which in this case I can't see. If it looks like the foil is loose, which in this case it doesn't look like it is. And so once you've done your visual check, then you will rub gently. You don't want to scratch the paper or anything, but you're going to rub the outside, the open end, in that circle. Just like that, so that if there is any loose material, this should be far away. I shouldn't be leaning on this because that's radiation coming through that box. Anyway, you do this, blah, 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 and then you pop it back in the box, close the lid, and put that back in the safe far away. Called it a safe, I should have called it a radiation store. Anyway, that is now ready to go. So this piece of filter paper has to go under the Geiger Müller tube. And it goes under the Geiger Müller tube so that the circle that has been, well, potentially contaminated is underneath, directly underneath where, whoops, don't move it, directly underneath where the Geiger Müller tube opening is. So there we are, that's good enough. That's why they want a 2 centimeter or 20 millimeter diameter, so that it goes under there. Then, same method as before. What are we going to do? Reset the stopwatch and reset them both at the same time. And then we time this for 100 seconds. So that's 1 minute and 40 seconds. Now, the source has passed the contamination check if the number of counts we get in 100 seconds is less than double the background count in 100 seconds. So this will include background radiation, and that's correct. We don't subtract background from this, we just take this number of counts in 100 seconds and compare it to the background count in 100 seconds. And if the number of counts with the source there is less than half of the background, then, and it's passed the visual check, then this has passed. Brilliant. But what if it doesn't pass? Well, if it doesn't pass, then we have to decontaminate it. So what that means is taking the source out, just like this, taking a lint-free cotton swab, just like that, and some ethanol. And you can use just basic cleaning fluid, but ethanol seems to work quite well. So I'm going to do some decontaminating. I'm going to put some gloves on. There we go. These are the largest gloves we've got. They barely fit me, but okay, we're not doing this for comfort. We're just doing this for a little bit of protection. There we go. Then we're going to take a cotton swab. Actually, first of all, let's get the source out. Put that there. Let's pretend that the alpha source, this one here, the plutonium, has got some sort of residue on it. It's failed the contamination check. Oh dear, we need to decontaminate it. So we take that out very carefully. Here I've got a container that contains a bit of ethanol, cotton bud. Squeeze it out around the outside. You don't want a lot of ethanol, just a little bit of ethanol on this cotton bud. This is a lint-free swab. And holding the source firmly, we just give it a bit of a wipe around. And on the bottom as well, give it a bit of a wipe. Just like that. Give it a bit of a clean. Don't put it back in, because that might be contaminated. So don't put it back in. You can then wait for it to dry, check it on the filter paper again, see if it passes the second time. And in fact, while I've got this out, I might also show you how to decontaminate the lead. Same thing, a little bit of ethanol, and then wipe around the swap hand so you can see it. Wipe around the inside of this, all the way deep inside. Give it a good wipe, not too wet. Just give it a good wipe, clean up any sort of residue that might be there, and then test it again once it's dried out. And you'll notice that on the cotton, the swab here, the lint-free swab, you see there's a sort of a grey residue on it. That's probably iron oxide or something like that, but it might not be. So this is now low-level radioactive waste, and that needs to be discarded properly, which means via the dustbin route, because it's going to be low level. You can always check it with the Geiger counter if you want to. So how do you dispose of this via the dustbin route? Put it in a black bin bag, in amongst all sorts of other rubbish, loads of other rubbish, and then wrap in another black bin bag, and it goes out with the normal waste. And there are rules about how much you can put in, how much normal rubbish there has to be in with it, all that sort of thing. And it's all in L93, so I can't remember all the rules. They're all written in L93, so you can check them. So that's the gloves as well, count as low-level waste, so they would have to go into the rubbish as well. Just take them off. And that is how you decontaminate all these sorts of things. Very, very straightforward. Give it a bit of a wipe, leave it to dry, test it again. If that hasn't worked, give it a wipe, test it again. And if eventually you just think, no, this isn't working, there's something wrong here, that's when you'd contact your RPA and say that something's wrong, I can't decontaminate this for whatever reason, come and help me. Now with certain sources, like the radium source, it's quite likely actually that you're going to get the container contaminated. The container will be contaminated because the radium will decay into radon gas, and the radon gas would be adsorbed, onto the lead oxide, and so the lead oxide will become contaminated. So how do you check to see whether this is contaminated or not? Well, you do the same thing. Now this is the circle that we're going to test. So we can fold this now, and the idea is to fold it, scrunch it, so that that end is going to be able to stroke, to wipe all inside there. So maybe a little bit narrower. Obviously, I've already decontaminated this. Maybe wear gloves, but there we go. Right in there, give it all a good wipe all the way around. And then, again, wearing gloves in case it's contaminated. Open it up, flatten it right out, because you don't want the Geiger-Müller tube touching that. If that's contaminated, you don't then want to contaminate the Geiger-Müller tube. So you flatten it right out, put it back under the Geiger-Müller tube, do the same test, and again, it should be not as high as double background radiation, including background radiation, when counted over 100 seconds. And if it's not, okay, if it doesn't pass, make a note of it in your log, clean it, decontaminate it, check it again. Clean it, decontaminate it, check it again, until it is. And if it's causing problems, then contact the RPS. Sorry, I meant to say contact the RPA, not the you are the RPS. Contact the RPA. Now, if you're checking things like the bottle of protactinium, same thing, do a visual check, make sure there's no evidence of leaking or damage. Then give it a wipe around the outside, especially where the seals are. Give it a good wipe with the With the filter paper, again, making sure the circle bit is the bit that you're touching when you're wiping. Exactly the same thing. You take that filter paper, put the circle onto the Geiger-Müller tube aperture, and then measure the count rate over 100 seconds, measure the number of counts, and it should be no more than, it shouldn't be double, it shouldn't be as high as double the background radiation, and it includes background radiation. Okay. In terms of documentation, there's a lot of stuff that you really ought to have. And there's a checklist, 16.1 from L93 that you can use. We're still kind of working through it, but I'll show you the basics of it. There's 2 copies of it. I'll show you the basics of it. You need to have a record of all the sources you've got. It's a good idea to give each of your source a unique identifier. So we number all ours with letters and stuff. That's okay. Any sources you've got at all should be here. Whether you're disposing of it or not, it should still be recorded here. If you know the radionuclide, you can list it there. If you know the original mass or the original activity, which is often written on the box, record that. And there's a handy conversion table on the document that you saw before where we were calibrating, there it was, where we were checking that the Geiger counter was fine. There's a handy conversion there for different activity units. And then CLIAPS guidance. These come from the risk assessments, the specific risk assessments, which again are on L93. So you record all the sources you've got, and you're not really allowed to hold any sources other than what you use. So most sources are going to be this 8A cup type source. You might have the odd Panax source, protactinium generator, and each of these has some specific information down here. Leak check annually, or if damaged, wipe around cap in any suspected areas, but do not open the bottle. Container check annually, or if leak is suspected, check the container that the bottle stands in, clean as necessary, blah, blah, blah. So it's all there, exactly what you need to do. So not required for cup sources, the contamination of the container, unless it's radium, for reasons I've already mentioned. And don't be alarmed if it looks really contaminated, if it's radium. That's quite normal because of radon being emitted. Thoriated tungsten welding electrode. The one we've got's actually got a yellow tip, not a red tip, so that's 1% thorium. The red tipped ones are 2% thorium. So we've got one of those, so I put the specific risk assessment in. We've also got a little bit of this, which we're not allowed anymore, so we're organising for that to be disposed of. See section 12, and there's a company that has to come and take that away. Because it's uranium and thorium, you can't get rid of them via the dustbin route, they have to be taken away. It's expensive, but it's necessary. Standard operating procedures, you can just steal this stuff from L93, just make sure you put the name of your RPS and all the other details in there. Managing incidents involving radioactivity, it's worth having that printed out. It's not many pages, but it's worth having it in case something goes wrong somewhere. You know, the source is lost or stolen. You don't have to frantically guess. You can just have a look. There's the reporting thresholds there. About the type of detector, I have that in there as well. That record you saw before where I was testing that the Geiger-Müller counting system, the Geiger counter was all okay. You keep them in here as well. We've got 2 Geiger-Müller tubes, so I tested them both. Only got 1 lead though, but we've got 2 tubes. Then we've got every source has its own record of its history, every source. And what you do is you fill in it's useful if you have a unique identifier for each source. So you fill in the information, if you know the radionuclide and so on. Go through here, you don't know any information. If you don't know any information, just leave it blank. Don't make it up, don't blag it, just leave it blank. That's 33.7 counts per 100 seconds, averaged over 1,000 seconds, which is what the instructions say to do. And we got 34 counts in 100 seconds, so that's fine. It needs to be at less than half of what that is, including background. The container in this one actually passed the contamination. 64 counts in 100 seconds when I swabbed the container is less than 67, which would be double this. So that's okay, but only just. So I decontaminated that anyway. Whereas the others, that failed decontamination. So I did it again. I cleaned it all down, decontaminated it, then did background again, 25.8 this time. And then this one measured 42 after decontamination. So that was fine. So that's the way it is with these. Radium often needs decontaminating that one, organising for that one to be disposed of, and so on. These are the useful documents to have. You should have these for every source. You should have these. So that at the end of the life of the source, when you want to get rid of it, that can be recorded on here as well, disposal route and details. And every year when it's checked, it can go on here and you can go on additional paper if needed. This one's an interesting one because it failed the contamination check first time. This is radium, yet again, radium being a nuisance. Failed the contamination check first time for the actual source. So visual, yes, but it still failed. So I decontaminated the cup source and I decontaminated the container, and then it was fine. So that's not unusual. Don't panic when that happens. You just got to decontaminate it, clean it up, and then test it again. You should also have a record of who is authorised to use the sources and what courses they've done. I'm still filling this in. I'm hiding their names and the name of the school so that their privacy is preserved, but that's an easy list to keep. It's not a big deal. Then you've got these tests, these checks, these monthly checks. They should be done every month. Not a difficult thing to do. You don't have to actually do the leak test every month. Just check that it's still in date, and if it isn't, then you can go back and do the leak tests there, leak and contamination checks there. And that's pretty much it, I think, in terms of documentation.